I'm really sorry about the delay. This is the last class that we're going to have on Trig. And what I wanted to do with you today was just talk about identities. The first thing that I just wanted to say about proving identities, it's something that you're exposed to in grade 11. And it's very important that you don't see an identity as an equation. You're not solving for a variable or for an unknown value. You are proving that, oh gosh, how terrible of me. Sorry, Hugo, I didn't even introduce you. I beg your pardon. Um,
No problem.
everybody, everybody tonight, we've got Hugo standing in for Yolanda. She's not well at the moment. So thank you so much, Hugo, for being here and for doing such a fantastic job to help the students and I with this lesson. Yes, Hugo's absolutely passionate about his maths. He's still got all his maths books from when he was in matric because he loved maths so much. So you are in good hands, matrix. Okay, so yeah, please, you can ask him or you can ask me. So yeah, no problem at all. Thank you, Hugo. When we are proving identities matrix, as I was saying, you are not proving, you're not calculating the value of an unknown. You are working with an expression and proving that when it simplifies, it would be equal to whatever is given to you on the right-hand side. So it's very important that when we approach these questions that we know how to do it as well. Okay, so we've got to split the left and the right-hand side. We cannot work with the two of them together. We cannot do something to the left and do something to the right-hand side. It's not an equation. So either you're going to work with the left or you're going to work with the right, but you can't work with both of them simultaneously. The other thing that's important are all our identities and our double angle and compound angle formulae. So remember our tan identity from grade 11, tan theta is equal to sine theta over cos theta, and our square identity, sine squared theta plus cos squared theta is equal to 1. Often we are given the number 1, and if we can't cancel it out, we would write it as sine squared theta plus cos squared theta. Do not forget about your double angle and compound angle formulae. So we need those next to us while we're able to do this. I've taught many matric students before and they don't expand them properly because they don't look at the formula sheet. So please, when you're working with double and compound angle formulae, they are given to you. Make sure if you don't know them off by heart that you copy them down correctly. Some other things that we're going to need to be able to do when we prove identities is we've got to be able to work with fractions. Okay, so specifically adding and subtracting of fractions is very important. We've got to be able to find a lowest common denominator and then simplify from that point onwards. And the other thing that we have to, big thing that we have to be on the lookout for all the time is factorizing. Okay, factorizing is very, very important because we cannot cancel over plus and minus signs. So we always have to be able to take out a highest common factor or factorize difference of two squares or factorize trinomials. I've never seen, I have seen grouping, but I've never seen sum or difference of two cubes in identities. But just because I haven't seen it doesn't mean that somebody somewhere might not ask it of you. I do need to talk to you a little bit more about addition and subtraction of fractions, but I'm going to do that in my examples rather than as something separate. Okay, the factorizing is also something that is going to come up. So the first example is very simple, very straightforward. And the first thing I want to do is split it up. So left-hand side is equal to 1 minus cos 2 theta over sine 2 theta. So with cos 2 theta, there are 3 different ways in which I can write this. Okay, so either I can write it as cos squared A minus sine squared A, or 2 cos squared A minus 1, 1 minus 2 sine squared A. What I want to try and do is try and write it in such a way that I can cancel out this 1 in the front. So which one of the 3 do you think I should use? I want to get rid of the 1, use a formula that's going to allow us to get rid of the 1. Which one would we use?
1 minus 2 sine squared theta.
That's it. Okay, the third one. Brilliant. So I'm going to sub in, remembering to use brackets in front of my or behind my minus, 1 minus 2 sine squared theta. And then at the bottom, I've got sine 2 theta. I can only write that in one way as 2 sine theta cos theta. Now I'm going to get rid of my brackets. That's going to leave me with 1 minus 1 plus 2 sine squared theta over 2 sine theta cos theta. Now, originally at the top, I had 2 terms. I then changed it into 3, but the 1 minus 1 means that that has now cancelled out, and I'm simply left with 2 sine squared theta over 2 sine theta cos theta. And now that you have factors, you can now cancel down. So we can't cancel terms, we can't cancel over plus and minus signs, but we can cancel these. All right, so 2 divided by 2 we know is 1, and then we can say sine theta goes into itself once and into sine squared theta, sine theta number of times. So this means matrix that we've got sine theta at the top, cos theta at the bottom, and then we can use our tan identity to write this as tan theta like so. Okay, so that just gives you an idea of how to set it out, the identities that would be used, etc., etc. Are there any questions? This is a very simple one. Any questions? Okay, Katlejo, can you be a little bit more specific about what it is that you don't understand? Yeah, please remember you can ask Hugo as well. All right, so we wanted to cancel out the 1. We wanted to get rid of the 1. Okay, we want to get rid of this 1 over there. So that's why I picked 1 minus 2 sine squared theta, so that 1 minus 1, that's how I'm going to get rid of the 1. Okay, by using an additive inverse so that it adds up to 0. So remember, I cannot cancel over plus and minus signs. So if I only have factors, then I can start canceling and I don't have to factorize. Okay. But I'm not always going to get rid of the 1. Sometimes I've got to keep it and I've got to do other things with it. Okay, so in fact, there's 3 different things we can actually do with 1s in these. All right, is everybody else okay? Are we thumbs up? No, Raphael, you won't. It's not necessary to do that. You can if you want to, but you're not going to get any marks. So here you would get marks for, sorry, I should have explained that to you. You would always going to get marks when you use identities. So a mark there, then here probably a mark on simplifying, and then your last mark would be over there. Asanele, do you have a question? You're more than welcome to ask.
Good evening, ma'am, and good evening, everyone. Can I please ask if your final answer should be tan theta or should it be sine over cos?
It should be tan theta because that's what was given to you. Okay, so
Ma'am,
you need.
sorry to disturb, but my extra classes teacher told me that putting the last answer as tan theta is not the right way to do it.
Okay, maybe your teacher was talking about something in a different situation or a different context, but I can assure you that there's absolutely nothing that you've done
Wrong
here
with
that would
it.
be absolutely, because that's the whole idea, is that you're starting with the one side and you're getting your answer to equal the other side. So what your teacher might have meant is that if you've got sine theta over cos theta and you're needing to work with it further, you wouldn't write it as tan theta. You always write tan theta, sine theta over cos theta. That's probably what your teacher was trying to say to you. So I've actually got a question in here, this one over here, where I'm going to show you we wouldn't leave this as tan A. We would write it as sin A over cos A. But here
Oh,
specifically, you are trying to show that the left-hand side equals the right-hand side. So it is important that you're not going to get a mark for it. You're not going to get a mark for the tan theta, but you will get a mark for the sine theta over cos theta.
thank
Okay.
you, ma'am.
All right.
Thank
No
you.
problem.
Thank you.
No, it's a pleasure. It's a pleasure. No problem at all. Okay. So, I've got two rather simple questions that I want you to try. All right. The first one is, it's a very important conclusion that we need to come to in trigonometry. So I would like you guys to give this a try. I don't want to spend too much time on this because I'm kind of hoping that we can get into some of the sort of slightly more difficult questions. Remember, guys, when you are squaring a binomial, you're multiplying the bracket by itself. Okay, so you've got to think about it in algebraic terms as well. Okay, so there you go. You can either do A or you can do B. I'm going to give you guys 5 minutes and then we're going to mark what we've done. Okay. Remember, if you've got any questions, you can ask Hugo as well. Yes, you must expand the brackets, Rebetsware. Pinker, when you say, is it okay to prove the right? Oh, you mean, can you start with the right-hand side? It's absolutely fine, Pinker. In some situations, you have to work with the left-hand side and the right-hand side, just not at the same time. So if you want to start with the right-hand side, you could do that in this question for A, certainly. Because there is an identity there that you can work with. Correct. It doesn't. Cool, Zandile, well done. Logi, well done. Sure, you guys are flying through this. Well done, everybody. Done with A, nice. You can try B, unless, of course, you have done that already. Cool, Sinan Kosi, well done. Okay, Asanele, you're done. Claugie's also done with B. I'm sorry, Palesa. I know these are difficult. When we start to get to identities, then things really do start to become quite a bit more difficult. Okay, well done, everybody. So let's just go through the answers. Palesa, you're not alone, okay? There are a lot of people that struggle with identities. These are difficult. Okay, and also our algebra needs to be really, really good to be able to do these as well, which can also sometimes create a bit of a problem with us. Okay, does anybody want to tell me what they did for A? Anybody feeling brave and wants to share their answer? Asanele, go for it. Go for it, Asanele. What did you write?
Ma'am, I'm not too sure, but then for the first question, for in the brackets cos theta plus sine theta, you square the first and then you square the last and then you multiply them and then add 2 in the front.
Okay, so in other words, what you're doing here, when you've got cos theta plus sine theta squared, you are multiplying that bracket by by itself. So did you write this, what I'm writing on the screen at the moment? Did you write that?
No, ma'am, I wrote cos squared. No, ma'am, I think I skipped that part. But
Okay.
I wrote it as cos squared theta plus 2 sine theta cos theta plus sine squared theta.
100%. Okay, very, very nice. Now, I didn't go, that's perfect. I didn't go straight to that step because I didn't know whether there would be people that would be confused if I did that first, but that's absolutely correct. That's where it comes from. So there's nothing wrong with you doing that. Okay, so cos squared theta plus 2 sine theta cos theta plus sine squared theta. And then what did you do after
sine
that?
squared theta. After
Yes.
that, I took ma'am, I wrote cos squared theta. And then I took the last plus sine squared theta and put it instead of at the end, yes, ma'am, there. And then I wrote plus sine 2 sine theta cos theta.
Lovely.
And then I recognize the first one as the identity that we learned in grade 11, the one that equals 1. And then plus, and then that one, the last one is the identity that we learned in grade 12, which is sine 2 theta, which equals the left-hand side. Thank you.
It does. It certainly does. Very, very well explained. Okay, Asanele, brilliant. Good job. Very, very nice.
Thank you, ma'am.
Thank you so much for your answer. All right. Anybody else feeling brave and wants to tell us what they wrote for B? Anyone else want to tell us what you did for B? We're not feeling like...
Can you please ask a question before you go to B?
Sure, Katleho. What do you want to ask?
Ma'am, can you please re-explain the second last step? How did you go from this one?
Okay, so the way Asanele explained it was absolutely perfect. What she did is she took the first term over here and the last term over there, and she put them together at the front like this. Okay, and she said, well, from grade 11, you know that cos squared theta plus sine squared theta is equal to 1. So that's where she got the 1 from. Does that make sense to you? And
yes,
then, okay, and then this is your sine double angle. Okay, so that's where she got this from. Right, maybe it will help if I put this down here. Let's put it over there. Okay, so let's just highlight it. Okay, so it's that one over there. That's what she's done at this end bit over there. Okay, Ola, do you want to ask a question?
Evening, ma'am. Yes, ma'am.
Yes, go for it.
Ma'am, what if we didn't put the cos squared theta and the sine squared theta together? And we just wrote the 1?
That's also fine. That's also fine. Yeah,
Okay.
absolutely not a problem at all. You could do that too. Here, what would happen is that you would get a mark. You wouldn't get a mark for writing a bracket times a bracket in matric, but you would get a mark for multiplying that out. You probably are not going to get a mark for this line anyway. Mind you, actually, yeah, I don't think so. I think it would be absolutely fine if you didn't do that. It's not a problem at all. This is a very, very simple one. So there isn't really much to give you marks on here. But yeah, absolutely. That's
Okay,
fine.
thank you, ma'am.
You wouldn't lose out. Okay, so can we do B now? Are we ready for that? So you need to look at what's on the right-hand side to give you some clues as well. So you can see on the right-hand side, you've got cos x plus sine x. At the bottom, you've got cos x minus sine x. So you've got to look at what is on the right-hand side as well as what's on the left-hand side, and then decide which double angle formula you're going to use. So in the case of question B, which one do you think is a good idea to use for cos 2x?
Ma'am,
Yes, Sandile.
ma'am, it's the very first one.
The-
Cos squared x minus sine squared x.
Lovely. And Zandile, what did you do after you'd written cos squared x minus sine squared x and you'd written the denominator? What was your next step?
My next step is I realized that it was a difference of two squares. So
Good.
and then in the first bracket, it was cos x minus sine x. In the second bracket, cos x plus sine x.
Very nice.
Oh,
Well done.
all
Keep
over
going.
cos x minus sine x.
Lovely. Keep going. Keep going. I love what I'm hearing.
Then the cos x minus sine x on top. What's this word?
Cancels.
Cancel out with the one underneath, leaving you with cos x plus sine x.
Lovely. And that's equal to the right-hand side. Okay, very nicely explained. That was brilliant. Well done. Very, very good. Okay, so a mark for that. Definitely a mark for factorizing, possibly even a mark for cancelling down. What I want to ask now, is there anybody that did not factorize in this line over here and cancelled cos x at the bottom with cos squared x at the top? Is that allowed? Is it okay to do that? Did anybody do that instead of factorizing? No. Okay, Asanele says no. Good. I'm glad to hear it. Okay, because that would be incorrect. All right. Remember, you cannot cancel over plus and minus signs. You did that, Lutando. Okay, Chrissy, you did. Okay, so that's a very common mistake. Then you got stuck. Okay. All right. Now, the reason why that doesn't work, matrix, is because if you cancel over plus and minus signs, look at what happens here. If I take something like 2 plus 7, and at the bottom I have 3 plus 7. If I go ahead and cancel out my 7s, I'm saying that 2 plus 7 over 3 plus 7 is equal to 2 over 3. But if I do it a different way, and I add my numerators together and I add my denominators together, are 2 over 3 and 9 over 10, are they equivalent fractions? Is 2 over 3 equivalent to 9 over 10? No. Okay, so you cannot cancel over plus and minus signs. Okay, so you can't say here cos x goes into itself once and it goes in here cos x times. And same thing with the sine x. You can't do that. Okay, it doesn't give you the same answer. All right, so pluses and minuses are there to remind you to factorize. Okay, so something that's a good thing to learn for you going forward is that cos squared a minus sine squared a is difference of two squares and can always be factorized in order to help you in identities and in equations. Okay. All right. And you know what? Mistakes are good because this is how we learn. If you hadn't made that mistake, you wouldn't know that. Okay. And you would carry on making that mistake. All right. Let's jump into something that is, yes, we're doing identities. We're doing proving identities, Cabello. Okay, Ria. All right. The more you practice this, the easier it will become. Okay. So the next question I've got here is meant to be quite a bit more difficult. All right, so hopefully now we're feeling a little bit warmed up and we're ready to take on something that is a bit more of a challenge. Okay, if you have a look at the identity that they ask us to prove in number 1, you can see that we've got tan A on the left-hand side, and on the right-hand side, we've got double angles. So I could work with the left-hand side and I could work with the right-hand side in this particular case. All right. What's important is that you cannot work with them together at the same time. So what I'm going to do is I'm going to do it traditionally, and I'm going to start with the left-hand side, because there's something here that I want to point out to you. All right. Now, going back to, I can't remember who said this in the beginning, but we were talking about the tan identity. When we see tan A, we want to write it as sine A over cos A. So 1 minus, and then I'm going to put sine A at the top, and I'm going to put cos A at the bottom. And this is all over 1 plus, and again, I'm going to write tan A as sine A over cos A. Now, the 1 here is very interesting. Okay, I can't get rid of it because it's not like a cosine double angle where I can pick which one I'm going to use to get rid of a 1. So I can't get rid of that 1. Do you think that it would be helpful for me in this scenario to write 1 as sine squared theta plus cos squared theta? Is that going to help me? Yes or no? Please, can we mute? Please, can we mute? Thank you. Okay, I'm glad to see all these people saying yes, because the answer is actually no. Writing 1 as sine squared theta plus cos squared theta here is just going to make this identity an absolute nightmare to work with. Right, so I don't know if you remember me saying earlier, there's 3 different things that we can do with 1. Yeah, true story, Ria Betsway. There's 3 things that we can do with 1. Either if we've got 1 combined with cos 2a, we can eliminate the 1 by choosing an appropriate double angle identity. Or we can write 1 as sine squared a plus cos squared a. The third and final thing that we can do with 1 is we can always write 1 as something divided by itself. Okay, this is something that we know, but we don't actually think about. Yes, there are 3 different things that you can do with 1. Now, remember at the beginning, we spoke about how when we are adding and subtracting fractions, we have to find a lowest common denominator. So essentially what you've got here is you're now working with a fraction, because tan A is sine A over cos A. It's a fraction. If I wanted to make 1 into an equivalent fraction with the same denominator, how can I rewrite 1? I can rewrite 1 as, this is, I think, very clever. I can rewrite 1 as cos A divided by cos A. Exactly. Minus sine A over cos A. And instead of me writing it as a complex fraction, I'm just going to write the divide sign because it's actually just easier in this case. And I'm going to do the same thing with the 1 at the bottom. I'm going to write 1 as cos A divided by cos A. Anything divided by itself is 1 plus sine A over cos A. All right. Now I've got fractions with the same denominator. Let me just move this. Ah, man, come here. I don't know why I never give myself enough room. I always think that I've got more space than I do, and I always run out. Okay, so I've rewritten 1 as cos A over cos A. And now when I subtract fractions, I need the same denominator. So I'm going to keep the denominator, which was cos A, and I'm going to minus the numerator. So I'm going to say cos A minus sine A divided by, I'm going to do the same thing over here. I've got cos A plus sine A over, and I'm going to keep my denominator cos A. Okay, how do we divide fractions, Matrix? Do you remember what to do with fractions? How do we divide fractions? Can anybody remember? So when we plus and minus, we have to have a lowest common denominator. Tip and times, that's it. Well done. Tip and times, or keep, flip, change. So cos A minus sine A over cos A times, and now I'm going to put cos A at the top, and I'm going to put cos A plus sine A at the bottom. And now I cannot cancel inside those brackets or inside those brackets. I'm not allowed to, okay, because then I would be breaking mathematical rules. But I am allowed to say that cos A divided by cos A is 1. All right, and now I would have cos A minus sine A times 1 at the top over 1 times cos A plus sine A down at the bottom. Okay, and then you can see that I still do not have what is on the right-hand side. Okay, I'm not finished. Okay, so this is this is a really big one. Okay, let's just see how we're all doing. Tip and times. Okay, so Lutando, cos A divided by cos A. In maths, anything divided by itself is 1. Okay, so cos A divided by cos A is 1 in the same way that 3 divided by 3 is 1. In the same way that x divided by x is 1. Anything divided by itself is 1. Okay, Lutando, go for it.
Ma'am, hi, can you hear me?
I can hear you.
Okay, how are you, ma'am?
I'm fine. How are you?
I'm good, ma'am. So as you're saying that anything divided by anything in maths can equal
So
what
as long as you do,
1.
yes, absolutely. So as long as you are dividing something by itself, your answer is always going to be 1, except 0. 0 divided by 0 is not 1. But any other
So
quantity in maths.
so I could say sine A over sine A even if I wanted to.
You
Just
could.
like for something else.
Yes, absolutely. Absolutely. Now, sine A over sine A would not be a useful way to write the 1 in this case, because then your denominators would be different. So what we're doing here is we're being clever in how we're writing the 1, because we're writing it so that we've got the same denominator, so that when we minus our fractions or add our fractions, we've already got the same denominator. Okay, so that's why.
For example, if the question was like 1 minus cos over sine A, and I decided to change the 1 into sine A over sine A to make the denominators the same, then it would be okay.
Then it would be okay. Yes, that's
Thank
the
you,
idea.
ma'am.
No problem. No problem. Okay. So, yes, we do. So when we are dividing, we're going to keep the first fraction the same, and then the fraction that follows the change of the sign from divide to times, that's the fraction that we do the reciprocal of, or write the reciprocal of. So what was in the numerator goes into the denominator, and what was in the denominator goes into the numerator. Okay. You know what, Ria Betswe? It's only because I've practiced and practiced and practiced, okay, because I'm old and I've been teaching maths for a long time. But believe you me, when I was your age and I was doing this for the first time too, I also didn't think it was easy. Okay, and unfortunately you haven't had as many years of practice, but you can do this, okay? Right, it's all the basics of the things that you know, you're just putting them all together. All right, now we can see that we still do not have what is on the right-hand side. So what we can do now, Matrix, is we can work with the right-hand side. I see there's some questions. Palesa, go for it.
Afternoon, ma'am. Can you hear me?
I can hear you.
Sorry to disturb. I just wanted to ask, why do we choose cos A over cos A? I mean, how do you know whether to choose cos or sine to divide by itself to get the,
Oh,
yeah.
okay, so that's fine. That's a perfectly good, reasonable question. All right, so my denominator here is already cos A. And my denominator over here is already cos A. So if I write it as cos A over cos A, then I don't have to choose a lowest common denominator because I've already got one. Okay, so in other words, I mean, it's a rather unusual thing to have, but let's say you had 1 minus cos A over sine A for whatever reason, and you needed to simplify that. Then here it would make sense to write this as sine A over sine A minus cos A over sine A. So that when you subtract your fractions, you've got a lowest common denominator, and then in the numerator you could write sine A minus cos A like that. Okay, so what you're doing is that you're looking at the denominator of the fraction that you are subtracting from your 1, and then you're writing 1 as your denominator over itself. Does that make sense?
Okay, ma'am. Thank you.
Okay. Now, Jessica, yes, you can use a conjugate to take you can continue to work with a conjugate over here, right? I wasn't going to do that because I didn't want to blow people's brains with the idea of a conjugate, but yes, that will work. Okay, remember with a conjugate, what you're trying to do is create a difference of squares. It's probably going to be the easiest thing to do in this case, actually. Okay, so a conjugate is when you multiply, let's say you've got x minus y, and here at the bottom you've got x plus y, right? When you multiply by a conjugate, you can't change the value of your fraction. So what that means is that you've got to multiply your fraction by 1. But again, you're writing 1 in a very specific way. So let's say I decide for whatever reason, I need x squared minus y squared in my numerator. I can then write x plus y at the top over x plus y at the bottom. That's multiplying by a conjugate. So again, x plus y divided by x plus y would be 1. When you multiply fractions, you're now multiplying numerator with numerator and denominator with denominator. So multiplying by a conjugate is another way to manipulate a trigonometric expression. Yes, to create a difference of squares, absolutely. So you can either create a difference of squares, sometimes multiplying by do you remember when you were in grade 11? I don't know if you remember seeing questions like this, but let's say you had something like root 3, I suppose it doesn't need to be root, over 1 plus root 2, and then you had to rationalize the denominator. I don't know if you remember doing questions like this. Then you would multiply by a conjugate. So you'd multiply by 1 minus root 2 over 1 minus root 2. And then that creates a conjugate. So you can get rid of the surd in the denominator. Does that ring a bell? Okay, so that was where we actually use it. So we can do it that way if we want to. Jessica, what would you use in this case? Bearing in mind, of course, that what we want is, excuse me, let's just go back and go and have a look at what we want. So we want cos 2a at the top. So what would you multiply by?
I would multiply by cos A minus sine A.
I would multiply, I would use a plus. Do you know why?
Why, ma'am?
Okay. Because at the top, on the right-hand side, remember you want cos 2a, don't you? At the bottom, you want plus sine 2a. All right, so if you want that, it means you're going to need cos squared a minus sine squared a. So that's why you want the two signs to be different.
Okay, ma'am.
Okay, does that make sense to you?
Yes, it does.
Okay, all right. And then you've got cos a, and then it has to be plus sine a at the bottom.
Oh, okay. So it's now it's the same way as multiplying by 1.
Exactly. Exactly. Okay. So you're not allowed to change the value of cos a minus sine a over cos a plus sine a. You've got to multiply it by 1. So the conjugate has to be the same at the top and at the bottom.
Okay, thank you, ma'am.
Okay. All right, no problem. So I'm really glad that Jessica brought this up, because I actually wasn't going to show you guys this, but you know, it's much quicker actually than working with the right-hand side, but we can go back and go and have a look at that if you want to. All right, now again, in order to be able to do trig, we've got to be able to work with fractions. We've got to be able to add, subtract, divide, and multiply, because now we're in a situation, Matric, where we're now multiplying our fractions together. So we want to multiply numerator with numerator and denominator with denominator. That's how we multiply fractions. So here we've now got cos a, whoopsie daisy, so easy to write the wrong thing, cos a minus sine a multiplied with cos a plus sine a, and then at the bottom cos a, yes, like it, sorry guys, cos a plus sine a multiplied by itself. Okay, so now at the top, you guys can see that that's something that would give you, if you were factorizing it, we would call it difference of squares. Okay, but I mean, we're not factorizing, we're multiplying out. Okay, so if we now do FOIL in the numerator, we would end up with cos squared a minus sine squared a. In the denominator, we would end up with cos squared a plus 2 sine a cos a plus sine squared a, and we are nearly there, Matrix. Okay, so cos squared a minus sine squared a is cos 2a. Using our square identity, cos squared a plus sine squared a, that would give us 1. And we know that 2 sine a cos a is sine 2a. And now you can see that the left-hand side does indeed equal the right-hand side. Okay. So a lot going on in that question. How do you feel? Does it make sense? Is it thumbs up? Questions?
Ma'am?
Yes, Katleho.
I feel like I wouldn't have known how to do this in like the exam. So thank you, ma'am.
Oh, it's a pleasure. It's a pleasure. That's
why what, ma'am?
That's why I want to do questions like this with you guys as well, just so that there's just a little bit of extension work as well. And we're not just doing the basic things, because unfortunately in the tests and exams, they don't just ask us basic stuff. They do ask us more difficult questions. So, you know, even if it's difficult for us to understand it at first, someone has to do these things with us, even if it's just an example that we can then go away and go and try ourselves. Okay. So well done. All right. So I see there's some thumbs ups. Okay.
Hi, ma'am.
Hi, Londeka. Do you want to ask a question?
No, ma'am. I just wanted to ask if we can like do conjugate in the next lesson, because this is actually easier with like conjugate. Without it, it was actually hard for me to do this. But with the concept that we're adding on it, it seems much more easier for
It
me.
is.
So I was asking if we can do conjugate maybe for like the first 10 minutes the next lesson, so we can get the hang of it.
Oh, okay. Unfortunately, this is the this is the last lesson that we're doing on Trig for now, but I am going to do lots and lots of revision lessons with you guys before you start writing exams. So yes, I will come back to this idea and I will find other questions that are similar to this one where I can show you this idea of the conjugate again. Okay.
Okay, ma'am. Thank you.
It's a pleasure, absolute pleasure. So also just to add in, guys, and I'm so glad that Jessica brought that up. Thank you so much, Jessica. If you did not use the conjugate, what you could have also done was go back to the right-hand side and work with the right-hand side alternatively and simplified that. And what you would have found is that you would have been able to simplify the right-hand side to cos A minus sine A over cos A plus sine A, and then you could have concluded that the left and the right are equal to one another. Okay, so that would be another way of doing it. Yeah, thank you, Jessica. I'm so glad you brought that up. I'm really pleased I was able to show you guys that. All right, it is complicated, Penga, but you know what? You've got to see, as I was saying, you've got to see these questions, because your tests and exams are going to have these kinds of difficult questions in them as well. All right, even if it's just an example that someone shows you, and that you go away and go and try at a later stage, you've got to see the difficult work as well. Okay. All right. Now, what I'd like to do, if I may, is just, and I'm going to give you guys a difficult one to try as well. I've got a hard one, maybe not as hard as, a slightly easier than this. It is the next question. Maybe that's what I should actually do now. Instead of worrying about doing this bit over here, where did it go? Oh, there it is. Okay, it's a little bit easier than what I've just done. Let's just do that until it's time to say goodbye. And then at least this gives you a little bit of practice with this. It's a little bit easier than what we've done, but try this particular question. Remember, if you're stuck, you can ask Hugo and I. Let me just get the, sorry guys. Okay, so we'll just try that and then we'll say goodbye. Okay, so you guys continue working with this particular question. All right. Lesedi, I know you were saying you're done, Cloggy. Oh, wow. Oh, speed demon, Cloggy. Lesedi, what is it that you were struggling with exactly in this previous question? I'm just going to move this question up with me, guys, so that I can just, so it's still on screen. There it is. Okay, so you guys can continue to work. Lesedi, what was it that you struggled with exactly here? The part of including the right-hand side with the left-hand side. Okay, so when you say including the left-hand side with the right-hand side, do you mean by multiplying by the conjugate, Lesedi? Yeah, absolutely. You're welcome to unmute if you want to. Okay, so essentially, everybody else just ignore me. I'm just talking to Lesedi. Continue with the question that we were busy with. I've got it up here so that I can do both at the same time. So Lesedi, the idea is, all right, that what they had given us on the right-hand side, they had given us that it was equal to the left-hand side, equal to the right-hand side. On the right-hand side was cos 2a, and at the bottom was 1 plus sine 2a. So I know that this is where I want to get to. If I want this, there are three different ways in which I can write this answer over here. I can either write it as cos squared a minus sine squared a, or I can write it as 2 cos squared a minus 1, or I can write it as 1 minus 2 sine squared a. That's the only way I can get cos 2a. So now I'm looking at my numerator. And I'm saying, yes, Katleho?
Can you just like bring up those identities?
Yes, sure. No, it's not a
Yes,
problem.
ma'am.
I can, there they are over there. So I'm just going to make them a little bit smaller. I hope you can still see that. There you go. I hope it's still visible. So the idea is you are trying to create cos 2a in the numerator. So you know that you can create cos squared a minus sine squared a if you multiply cos a minus sine a with cos a plus sine a, because that's difference of two squares. Okay, so that's what will help you create this cos 2a in the numerator. But you cannot multiply by cos plus a at the top and cos minus a at the bottom because then the top and the bottom are different. So it's not equal to 1. This entire thing here is also equal to 1 because anything divided by itself is 1. Right, so that's the idea behind a conjugate. So here it's that the sign in the numerator here and there are different to create this difference of squares, which you can then write as cos 2a. That was the whole idea. Okay, that's how we were tying the left-hand side to the right-hand side. So it's very, this is what makes the section difficult, is because you have to think through the question before you actually do something. You've got to think about, well, what am I trying to get to? How am I going to get to my answer? And you've got to plan what it is that you're going to do to get to those, to get to the answer, essentially. Okay. All right. So yes, the Trig link is done. Palesa says she's done. All right, so let's see if we can go through this now. I know some of you would have had to go because it's past 7 o'clock. If you do need to leave, you're more than welcome to. I just wanted to stay on a little bit longer just to give you a bit more practice. Yeah, absolutely. The quiz is very important. Yes, Ria, you can go if you want to. I'm just going to quickly whip through this with the people that want to stay. I'm not going to be on for any more than about another 5 minutes. Okay, let's just go down. This is just some more difficult work. Okay, let's just put it over there. All right, so guys, this is what we should have done. You cannot cancel out this one. Okay, because there's only one way in which you can write sine 2a, and that cannot cancel out the 1. So we want to write 1 as sine squared a plus cos squared a. Okay, and we're choosing to do that because there's no fraction here. All right, plus our sine 2a, which we'll write as 2 sine a cos a. And then here, oopsie, at the bottom, we've got cos 2a. So if we look at the right-hand side, this gives us some clues on how to write cos 2a. Remember, we want cos a minus sine a at the bottom. All right, so the best way for us to write cos 2a in this case is as cos squared a minus sine squared a. Now what I'm going to do is I'm going to rearrange. And I'm going to put the cos squared a at the front. I'm going to put the 2 sine a cos a in the middle, and I'm going to put the sine squared a, whoopsie, at the end. All right, and now we need to factorize. The numerator is a trinomial, so this is cos a plus sine a multiplied by cos a plus sine a. The denominator is difference of 2 squares. So this is going to be cos a minus sine a times cos a plus sine a. And now matrix, we can cancel that at the top with that at the bottom. And this gives us cos a plus sine a over cos a minus sine a. And then the left-hand side is equal to the right-hand side. There we go. All right, matrix. So we're going to have to bring our lesson to a close now. I will show you some more questions that you can try. The other thing that I think you probably want to take a screenshot of is our answer for the homework last time. Do you remember this? We did. Where's the question that I did for homework with you? Oh, yes, here it is. Do you remember I gave you this as homework? So if sine 38 equals p, express sine 19 in terms of p. We probably just only finished writing down the other thing and I'm already bombarding you. So you can take a screenshot of that as well, matrix. That was what you should have got as an answer. So that was the homework from the last time. Okay, I'm going to go back to the identities. Now, okay. And let's go here. Okay. What is a good thing for you guys to try here? All right. I would, if I was you, I would look at question 6, question 7, question 8. I mean, you can do question 5 as well if you want to. Let's just make that a little bit bigger. Sorry, now I've got these stupid stars in the way here. Okay, so if you want extra practice, question 6, question 7, question 8. These are sort of slightly more difficult questions. Okay, Matrix. Yes, Katlejo.
Hello, ma'am.
Hello.
Hi, ma'am. How are you?
I'm fine. How are you?
I'm fine. Ma'am, can you please explain the third step in the question we just did right now?
Sure.
Yeah.
The third step.
Yeah. Yes. The third step. I don't understand the third step. What is going on?
Let me just, where did I do it? Okay. So that would be. Do
From
you mean
cos squared A plus 2 sine A cos A. I don't understand why we took sine squared A to the
okay?
other side of.
Okay.
Yeah.
So what I was doing is I was making a trinomial. So what I had done is I took this cos squared A in the middle and I put it at the front. I took the sine squared A and I put it at the back. And I took the 2 sine A cos A and I put that in the middle. Okay, to make myself a trinomial. So algebraically speaking, I've got something that looks like this: x squared plus 2xy plus y squared. That's what I'm trying to
Okay.
do with it, so that in my next step, I can factorize it. So like this is also a perfect square trinomial. So this would be x plus y times x plus y, in the same way that this over here factorizes into cos A plus sine A times cos A plus sine A. Does that make
Okay,
sense to you?
Yes, ma'am. Yes, ma'am.
Okay, all right. And then once I factorize, remember, I can't cancel over plus and minus signs. I've got to factorize and then I can cancel down. Okay.
Okay, thank you, ma'am.
It's a pleasure. All right, guys, go and enjoy your long weekend. It's Easter. Hope you all have a wonderful Easter.